Voice is clear?
Yes, sir.
Okay. So this is your scheme of study or whatever you call it as the guide. In mathematics, you have one, two, three major topics that include factorization, coordinate geometry, similarity, area of similar shapes, and volume of similar objects. Okay. So do you understand the coordinate geometry that those lectures you have attended with Miss Vajia?
Yes, sir.
Is it okay if I start directly with the chapter 5 first, the similarity, and then the area of similar shapes and the volume of similar objects?
Yes, sir.
And then later on in the next extra class, I'll cover that factorizing thing. Okay? I think that's a
Yes,
part of algebra if I'm not wrong. That
yes, sir.
factorizing
Like
chapter 6.
completing the square and
Yeah.
quadratic equations and
Yeah,
simultaneously.
the quadratic one, the linear ones.
Yes, sir.
Okay, so let's start with the similarity. Look, let me tell you my way of teaching, my methodology. What I do, I first explain the topic to my students, okay? The topic, the formulas associated with the similarity topic, and then I directly jump on to the past paper questions so that to let you understand the difficulty level that you'll face in your assessment. Because you know that in Pisces, they follow book during the term, but in the assessments they set up the exam from the past papers. You know that. I think you've just started off with your eighth grade, so maybe you haven't done with any of the assessment. Is that the first assessment that is going to be in the first week of December, or are you done with any of the assessment before?
So we have done assessments in October, and in December we have first term final exams.
Okay, so did you notice that usually the teachers they set up the exams from the past papers, from the topical past papers,
Yes,
and
sir.
they have mentioned this in your study guide as well. So I'm not going to cover this 5.7a, 5.7b, or 5.7c, or 5.7d. The reason is because these exercises are just for you for your homework purpose or for your practice purpose. But believe me, they won't include any of the question from these exercises in your assessment. Okay.
Yes,
So
sir.
that is kind of a wastage of time because these, if you have checked these questions, they are way more simpler and easier than the questions those will appear in your exam. Okay. So the best part is to go directly to the topical past paper after, obviously, after making the understanding of the topic. Okay. Let me move this. This is the geometry section actually. Let me move this session there rather. Yeah. Okay. Section geometry. Okay. Let's start with the similarity. Congruency also included with the similarity, or is that just the similarity?
Sorry, sir. Your voice is not audible.
Yes. Is congruency also included, or is it just the similarity?
Sir, I'm not sure about that.
Okay, so let's start with the entire topic. You don't need to worry. We'll cover that in a quick way. Okay.
Yes, sir.
That's not. This is not a there is not a lot of content for similarity. similarity. So, what does
Sir, your voice
similarity
is cutting too much.
needs? Similarity is a phenomenon. No one complained, but let me check if I could switch my. Are you there?
Sir,
Yeah.
your
Let me
voice is
rejoin.
cutting too
Okay,
much.
rejoin. The issue is not at my end. I'm recording the class. You may check out the recording later on. Issue is not at my end. Maybe you're fluctuating. So rejoin the class.
Yes, sir.
Am I audible?
Yes, sir.
Is my voice clear?
It's a little bit cutting, but I can understand.
Okay, but do let me know if the we check whether that's your end or on my end. Okay.
Yes, sir.
Okay. So what is similarity? Similarity is a phenomena in mathematics where we have similar objects or similar geometrical figures. Okay. Then
Yes,
there is one more concept which is congruency. So we need to understand similarity and congruency in a parallel way. You can't ignore congruency when you're studying the similarity. Okay. So what does similarity means? Look, have you ever seen these kind of milk bottles? Obviously, I suppose your father works in Almarai, so obviously you've seen these bottles.
yes,
Now, let me show you which of these objects, or you could say which of these bottles are similar. Now, bottle number one, that is marked with
sir.
one, and yeah,
Your screen is. I can't see your screen.
means the screen is not shared. I'm really sorry, I forgot to share the screen. Rejoin the meeting and I thought that it's shared. Is it shared now?
Yes, sir.
Now understand the similarity here. Now we have four different kinds of milk containers, or you could say bottles. And bottle number one, that is marked with one, and bottle number three, they are similar. Why they are similar? Because they have the same shape, but with a different dimensions. Bottle number two is not similar to any of the other bottle because it doesn't have any similar shapes. Agree? So, what do you understand with the similarity? In similarity, shapes are same, but they do vary in size. Let us take an example of two similar triangles. Now, We have triangle ABC and triangle PQR. Irha, check out the angles of triangle ABC and triangle PQR. Do you agree that all the three angles are equal,
Yes, sir.
but the length of the side, does it vary?
Yes.
Does it vary in a certain ratio? If you check out side AB, it is 4 centimeter and the side PQ is 8 centimeter. Now we have AC as 2 centimeter and PR as 4 centimeter. Side BC is 3 centimeter and side QR is 6 centimeter. Do you think that there exists a ratio, there exists what you call it, a number that could be multiplied or divided to get the length of the triangle PQR?
Yes, sir.
Do you agree that the corresponding sides of triangle ABC and PQR, they have a common ratio, which means that if I multiply the sides of triangle ABC with 2, I'll get this length of the side of triangle PQR. Yes.
Sorry, sir, I didn't understand.
What I'm trying to say here is that the length of the side of triangle ABC, when they are multiplied with the 2, will get the length of the side of triangle PQR.
Yes, sir.
Is it correct to say that the length of the triangle PQR, the corresponding length of side of triangle PQR is 2 times the length of the side of triangle ABC?
Yes.
Yes. So this is called ratio. There exists a ratio between triangle ABC and triangle PQR, that the angles are equal, but the length of the sides are in a certain ratio, and that ratio is 2 times. If we double the length of the side of triangle ABC, we'll get the length of the side of triangle PQR. This is called similarity. Isn't it as same as the example of this butterfly? Are these two butterflies similar?
Yes.
But they vary in size. It's okay. In similarity, the size may vary, but the shape remains same. Another example is these marbles. Are these marbles similar?
Yes, sir.
Yes, they do. What about these? What I don't know what are they? I think they are lobsters or what? Or maybe the fish. Are they similar?
Yes.
Yes. And these aircraft models, they are similar as well.
Yes, sir.
So does these car models, they are similar. So does the bottle number 1 and bottle number 4. Sorry, bottle number 1 and bottle number 3. I think 4 is also kind of similar, but a bit different. Yeah, it's a bit different in shape. So bottle number 1 is similar to bottle number 3. We have another examples here. Maybe I've loaded these examples or not. Let me check. Yeah, we do have. Okay, so do you understand that similar objects, they have same shape, but their size vary? Agree?
Yes, sir.
Let us understand similarity verbally. In geometry, two objects are similar if they have the same shape or if one has the same shape as the mirror image of the other. More precisely, one can be obtained from the other by uniformly scaling. Have you ever seen scale models of aircrafts?
No, sir.
No? Any scale models of cars? Obviously, you'll see scale models of cars.
Yes.
Like we buy toy cars. Sometimes these
Yes.
toy cars are like BMW model toy cars, Mercedes model toy cars. Okay. So they
Yes.
are actually, this is called scaled models. Scale models are always similar. Okay. Possibly with additional translation. Okay. Now let's understand congruency. Congruency is very easy to understand. When the objects are exactly same, we call them that they are congruent. Exactly, by saying exactly same means this example. Check out triangle ABC and triangle PQR. Do they have anything different, any side, any angle?
No, sir.
They are exactly same. They have all the three angles equal. They have all the three sides equal. So this is called congruency. Do you find congruency easy?
Yes.
Now check this one. Do you understand that these two bottles, milk bottles, are congruent because they are exactly same in size and shape?
Yes, sir.
And then these six tins or cans are congruent. This one is congruent. The 330 ml can of Pepsi is congruent to the other 330 ml of Pepsi. Okay. So congruency means exactly same, but similarity means that they are same in terms of shape, but their size do vary. It vary with the ratio. If you check out triangle ABC and triangle PQR, every side of triangle PQR is two times the length of the side of triangle ABC. Agree?
Yes.
So the ratio must need to be same. It's not like this that one side is two times and the other side is three times and the third side is five times. No. If one side is two times of the corresponding side of the other triangle, then the remaining two length of the side must also be two times. The ratio must need to be same for the triangles to be similar. Got my point?
Yes.
Okay. Now, remember that we said corresponding sides. What does corresponding sides means? Do you have any idea about the corresponding word or the corresponding sides?
That
Yeah,
like uh in the triangle that is on your screen, the C is corresponding to R and A is
exactly.
corresponding to P.
A is correspond. Now, if we check out these two triangles, triangle ABC and triangle PQR, what do you think about that? Tell me which two vertices are corresponding or which two sides are corresponding. Okay, let me ask to check whether you know about the corresponding side concept or not. Let me ask you a few questions. Tell me which side is corresponding to which side of triangle PQR is corresponding to the side BC of triangle ABC.
QR.
BC, you said QR, but that's wrong. Let me tell you why. Now, please understand. I'll explain you corresponding. What does corresponding sides mean? Just in few seconds. Okay. Are you ready?
Yes, sir.
Okay. So, Ira, corresponding sides means the side of the one of the triangle or any shape that corresponds to the other triangle. Now, let me show you. What did I ask you? I asked you about the corresponding side of BC.
Yes, sir.
Now let's check which sides correspond to BC in triangle PQR. First of all, check out BC. Let me mark BC. Is that BC the encircled ones?
Yes, sir.
Okay. Now check, where do we have 65 degree in triangle PQR? On which
It's
vertex?
P.
It's P. So do you understand that P vertex corresponds to B or B vertex corresponds to P. Does this make
Yes.
sense?
Yes.
This corresponding concept is much important to understand because when we'll switch on to the similarity formulas, you need to keep that in mind that the formula could be only applicable onto the corresponding sides. Okay. Now tell me which vertex in PQR triangle is corresponds to vertex C of ABC.
Q.
Exactly Q. So Q corresponds to
C.
C. Okay, now you understand this one. So obviously A would correspond to
R.
R. Now keep that in mind and tell me which side correspond to BC. Which side of triangle
PQ.
PQR correspond to BC? Yeah,
PQ.
PQ. Exactly. Do you understand your mistake from the previous
Yes.
concept? Okay. Now tell me which side correspond to AC?
RQ.
Exactly, RQ. You need to call out the R first because I asked you which side correspond to AC. Now tell me which side correspond to CA?
QR.
QR. So that's how we say that the sides are corresponding. Do you understand why BA correspond to PR?
Yes.
Do you understand why BC correspond to PQ?
Yes, sir.
Okay. So let's So now this is why this is important because of the similarity formulas. You'll get it wrong. So AB is corresponding to RP, BC is corresponding to PQ, AC is corresponding to RQ. Now let's start with the similar. Any doubt in understanding what does similarity means?
Yes, sir.
No doubt
Sorry, sir.
until now, until whatever we have studied. Do you have any doubt until now?
No, sir.
Okay, now let's understand the three formulas of similarity. The first formula is L1 over L2 equals to H1 over H2. This is the linear formula. Why it's linear? Because we use this formula to find the corresponding length of two similar triangles. This formula is only applicable if the object 1 and 2 are similar. What does object 1 and 2 means? Look, this 1 and 2 is just there to differentiate between the two geometrical figures. Maybe one is referred as the first object and 2 is referred for the second object that is similar to the to number 1. So do you understand that the prefix 1 and 2 stands for just to differentiate the two geometrical figures?
Yes, sir.
It could be used as LA over LB equals to HA over HB. So you don't need to worry about the prefix. Just you need to remember that these prefixes, either we use one or two, or we use A or B, they are just there to differentiate between the length and the heights of the two objects. Okay.
Yes.
And formula number one is only applicable when you are finding the corresponding length of the two similar objects. Before you apply this formula, you must need to remember that this formula or these formulas, obviously formula number 2 and 3, which we're going to study later on, right after this formula, these formulas are only applicable if the objects are similar. So when they give you a question, they must mention it in the question that the two objects are similar. Then you will able to apply these formulas. Okay.
Yes, sir.
So L1 over L2 is equals to H1 over H2. Do you agree that this formula is just like a ratio between the sides of the two geometrical objects?
Yes, sir.
And isn't what similarity is all about? That there exists a ratio between the two similar triangles or similar objects.
Yes.
So this is ratio. Either you call it formula or you call it similarity ratio, doesn't matter. But you need to understand that how this formula works with the similarity. If you check out, they say that L1 over L2, which means the length of the first geometrical figure divided by the length of the second geometrical figure, okay,
Yes, sir.
equals to height of the first geometrical figure divided by the height of the second geometrical figure. Okay.
Yes.
Now, if by any mistake, if you use this formula like this one, L1 over L2 equals to H2 over H1, what do you think? What about this formula? Is this correct?
No, sir.
What's the mistake there?
It should be H1 over H2.
Exactly. Like the issue is that I have placed the length of the geometrical figure number one on the left side of the equation in the numerator, but on the other side of the equation, on the right hand side of the equation, I placed the height of the second geometrical figure in the numerator, which will obviously be considered as wrong. So you are not allowed to use this formula in this way. Moreover, but what about this one? The one that I'm going to write. L2 over L1 equals to H2 over H1. Is this one correct?
Uh,
Yes. Because you can flip the entire formula upside down. Isn't it the flipped version of formula number one?
yes, sir.
Exactly. So you can flip the entire formula, doesn't matter. You'll get the same answer, but you are not allowed to use different ratio on the other side. Do you understand what my point?
Yes.
So this formula is okay. Doesn't matter because you have L2 in the numerator and H2 in the numerator on the other side. Agree?
Yes.
So the ratio won't disturb. But using the different numerator on the either side, it will disturb the ratio. So the first formula of similarity is used to find the corresponding length or height or maybe width or maybe base or maybe radius or maybe diameter. This formula is applicable to linear units or linear dimension. Do you know about linear dimensions?
No, sir.
Look, when you get normal units like centimeter, meter, kilometer, these are lengths. They are linear unit. Why they are linear unit? Because these units have a, a power of one centimeter, meter, kilometer, millimeter, uh, uh, what else we have? Mile or maybe. And then we have square units. Have you ever seen a square unit before? Obviously, yes.
Yes.
Centimeter square, meter square. How do we use these? Where do we use these square units?
Centimeter square, meter square, we use for volume.
No, for area.
Yes, sir.
Square units are used for area and cubic units are used for volume. Agree or not?
Yes.
We find volume in cubic units because volume is a three-dimensional quantity. Now, you may ask me, why, what does three-dimensional quantity means? Tell me any formula of volume. Do you know any formula of volume?
Length multiplied by breadth multiplied by height.
How many dimensions you are using here to find
Three.
volume? Three. One dimension is length, other dimension is width, the third dimension is height. So when these dimensions have centimeter as units, and when you multiply these units, centimeter times centimeter times centimeter, wouldn't you get centimeter cube? What is 7 times 7 times 7? Is it okay to write it 7 cube?
Yes, sir.
X time x time x. Is it okay to write it x cube?
Yes.
So similarly, centimeter times centimeter times centimeter is centimeter cube. So do you understand what does three-dimensional unit means? When you are multiplying three dimensions, dimension means the sides of a geometrical figure.
Yes, sir.
And tell me any formula for the area as well.
Length times breadth.
How many dimensions you are multiplying?
Two.
So if the units are meter, then meters time meter will be.
Meter squared.
So do you understand that we use square units for the area because we have two dimensions in every formula of area? Like for example, area of triangle is
Half multiplied by breadth multiplied by height.
how many dimensions you are multiplying?
Two.
Yes, base and height. Half is not the dimension, it is just the number. So we are multiplying base with the height. So we are multiplying two dimensions. So obviously the unit must be in squares.
Yes,
Okay.
sir.
So now do you understand the concept behind two-dimensional and three-dimensional units?
Yes.
In short, what do we call two-dimensional? Yeah, think for a while. What do we, in short, what do we call two-dimensional quantities? Have you ever heard 2D or 3D?
Yes, sir.
Yes. Why we call it 2D? Because 2D means two-dimensional geometrical shape. Do you know any examples of two-dimensional geometrical shapes?
Uh, Rectangle, triangle.
Exactly. 2D shapes are triangle, rectangle, circle, rhombus, trapezium, kite shape, uh, a pentagon, hexagon. Are these two dimensional? Two dimensional are those shapes which you can draw on the paper. How many dimensions your paper have?
Two.
Two, which length and width? Agree.
Yes, sir.
And is it okay to call it X and Y as well? Because when you have a paper in front of you, it has length and width, which means it has X and Y axis. The vertical
Yes.
length is Y axis and the horizontal is called X axis.
Yes.
So do you understand that two-dimensional are those objects which could be drawn on paper?
Yes,
So we
sir.
call them 2D objects or 2D shapes. What are 3D? Do you have an example for 3D shapes?
Uh,
Yes.
uh, a cylinder
S-
or a sphere. A
ve-
sphere.
Very well done. Cylinder is one of the example. Sphere is the another example of three dimension. Can you draw sphere on the page?
Sir.
No, you can't. It's a 3D object. Okay. You can't draw sphere on the page because paper or page is
Two dimension.
itself two-dimensional. So it's not possible to draw 3D shape onto the paper. Although we try to draw. And what is cube? Don't you think that cube is also a three-dimensional shape? Because it
Yes,
includes
sir.
three dimensions and cuboid. Look, cube is the counterpart of square. In 2D, we call it square. In 3D, we call it cube. In 2D, we call it rectangle. And 3D, we call it cuboid. In 2D, we call it circle. In 3D, we call it sphere. In 2D, we call it circle. In 3D, we call it cylinder. Is it correct if I give height to the circle, it becomes if I pile up the coins, what they'll become? Would they become a cylinder?
Yes.
Okay, so in 2D, we call it, and then we have in 3D, we have cone. In 3D, we have pyramid shape. In 3D, we have prisms, cuboids, cubes, spheres, cylinder, frustum, cones. Okay, so do
Yes.
you understand that three-dimensional figures have three-dimensional units in cubes and
Yes.
two-dimensional objects have? And remember one thing that you could only able to find area for the 2D objects. There is no possibility of finding the volume of 2D object because there is no volume for 2D objects. And similarly, for 3D objects, you could find their surface area and their volume because 3D objects have multiple surfaces. Do you agree that a cuboid
Yes.
has multiple surfaces? How many faces or surfaces a cuboid has?
Length, width, and height.
Now, surfaces. How many surfaces a cuboid has? Suppose have you seen that what you call it uh, multicolored cube the game they used to play Rubik cube or what?
Rubik's Cube.
Yeah, where you need to match or where you need to rotate that entire cube to get the same color on either faces of the cube. Yeah, is that the
Yeah,
one?
yes, so it has six surfaces, top, bottom, front, back.
Exactly. Exactly.
That's
It
right.
has six surfaces. So you need to find the area of all the six surfaces. And then when you add that, those six surfaces, you'll get the surface area. So you could find that like for 3D objects, you can find either the surface area or the volume. But for the two-dimensional object, you can only find the area. And then here comes the one dimensional. Do you agree that length, height, diameter, radius, base, they all are one dimensional units?
Yes.
Because there is only one dimension. So do you understand why do they have one dimensional unit, centimeter, meter, and kilometer with no
Yes, sir.
power? So that's
Yes.
the concept for the 3D and 2D objects. Now, the first formula for the similarity is for the one-dimensional quantities, which mean when you're finding the corresponding lengths, corresponding diameters, corresponding bases, corresponding heights, corresponding widths, corresponding radii. Okay. And the second formula, which say A1 over A2, which means the area of geometrical figure 1 divided by the area of geometrical figure 2 is equals to the L1 over L2 whole square. Irha, why do we have a whole square there? Any idea? In formula number two. Yeah. Why do we have square on the left, on the right side of formula number two?
Uh, no
No
idea,
idea?
sir.
Is area a two-dimensional quantity?
Yes, sir.
And what units do we deal in area?
Square.
So do you understand that we need to take square on the length to make their units into centimeter square? Because length have, which unit lengths have? Centimeter, the linear unit. Now, do you understand the word linear when you have power
Yes.
1? So do you understand why do we have square on this area formula?
Yes, sir.
Because the dimensions, it's a 2D dimension and we need to convert. Look, what does equation means, Ira? Do you agree that equation means that but whatever do we have on the right side must be equal to the left side? Is that what equation means? Equation means equality. Equality means to keep the things balanced on the either side.
Yes, sir.
So to make it balance or to make it equal, do you agree that we need to take square of the length because the lengths have the centimeter or the linear units, and when we take the square, it becomes square units.
Yes, sir.
And do you understand that that same goes with the volume formula? Why there is a cube?
Yeah, because volume has three dimensions.
Exactly, because volume has three dimensions and cubic units. Exactly. Okay. Any doubt in understanding these three formulas?
Yes, sir.
Okay. So you don't need to memorize or cram these formulas. Just understand the logic behind these formulas, and then we'll apply these formulas. Once you'll apply these formulas to 3 to 4 questions, then automatically it will be saved in your brain. You don't need to cram these formulas. So formulas are not meant to be crammed or memorized. They are there to, and they are, these formulas are there so that you will understand the logic behind these formulas and then make the application, then apply these formulas. Okay.
Yes.
Any doubt? I think I hope that you already understand the logic behind these formulas, and now you don't need to cram or memorize these. Are they already saved in your mind?
Yes.
Okay, and you must need to have a good picture memory. If you have a good picture memory, you don't need to cram things. Just look at the formula, take just a virtual screenshot in your with your eyes and just save it in your brain. That's called a picture memory. Picture memories must need to, like, if those students with the bad picture memory, they suffers a lot. So you can develop picture memory by just focusing onto the picture and just stay your eyes there. Just keep your eyes focused onto the picture for certain seconds, for a while, and then just save it in your mind. Okay. I think you already take the screenshot, virtual screenshot in your mind for this picture that is
Yes,
on your
sir.
screen. Okay. Now we need to apply these formulas here onto the questions that are from the topic. Look, these questions are from topical past papers. And I hope, I'm pretty sure that in your assessment, they would obviously include these questions because they won't include questions from your exercises. They must include questions from the past papers. Okay.
Yes.
Now, Ira, we are halfway to the class. It's being 45, 47 minutes. We'll have a 1.5 hour session today. So I need a 5 minute break now. Okay.
Okay, sir.
So just go and hydrate yourself, drink some water, move around, and then come back after 5 minutes. Let me take 5 minute break. Audible?
Yes, sir.
You just give me one more minute. I need to erase the previous working, okay?
Yes, sir.
My screen shared.
Yes, sir.
Okay. Let's start with question number two first. So, in question number two, triangle ABC is similar to triangle PQR. Okay, the first point. Okay, one thing I need to mention here, Ira, that always remember that in mathematics, solution always lie in question. Okay, it's always hidden in the question. The answer is always hidden in the question. You just need to read out the statement correctly. If you read the statement in a wrong way, obviously you will not reach the correct solution. So, question number two, triangle ABC is similar to triangle PQR. Did they mention that the two triangles are similar?
Yes, sir.
Now, this is the most important part here. Why? Because they have already mentioned that the two triangles are similar, which means that you can apply the similarity formula here. Is similarity formula applicable here?
Yes, sir.
Yes, because they have mentioned this thing that the two triangles are similar. The other point is that the way they write the name of these triangles, you need to extract the corresponding side. So what do you think? A corresponds to what in PQR?
P,
Exactly. And then B corresponds to
Q,
Q, and R corresponds to C.
C.
Why it's important? Because once you apply the formula, you need to keep that in mind that which vertex or which sides are corresponding. Okay. Now, in triangle ABC, they provided you with the two length of the sides, which is AB as 5.2 centimeter and AC as 12.4 centimeter. And in triangle PQR, only one side is there, which is PR. So do you agree that PR is PR corresponds to AC?
Yes, sir.
Because some like this is very easy question. Sometimes they rotate the triangle, sometimes they change the vertex just to give student a tricky question. Okay.
Yes.
Now, because the two triangles are similar and they want you to find PQ. Is PQ one dimensional? Is PQ a length? Yeah.
Uh, is the PR is the length?
PR is the length. PQ is also the length.
Yes.
So, which formula we use? Number one, two, or three?
1 L1 over L2 equals H1 over H2.
Exactly. L1 over L2 equals to. Now, although there is no height, but you don't need to worry. The formula will work for every one-dimensional unit, okay? Now, what I'll do, I'll keep the L1 as whatever we need to find. So I'm taking L1 as PQ, okay? I'm taking
Yes.
L1 as PQ, which means that just for your ease, remember that like I'm taking this one as triangle number one and this one as triangle number two. Okay. So L1 must be PQ. Why? Because we need to find that. So it's like we can use the formula in other way, but the best way is to keep your unknown in the numerator. Okay. So my unknown is PQ, what we need to find. I'm keeping it to numerator. So PQ is the numerator divided by L2. What is the corresponding side of PQ in triangle ABC?
AB will correspond to PQ.
Okay, so AB. And now on the other side, obviously,
PR.
H1, any side of triangle number one. Do we have only one side of triangle number one? That is 21.7
Yes.
divided by the corresponding side of 21.7 in ABC is,
AC.
which is 12.4.
Yes.
Now we rearrange to find PQ. So AB is dividing on the left hand side. Do you agree?
Yes.
So when it moves to the right hand side, it must multiply.
Yes, sir.
And what is AB?
5.2.
So is it okay if I replace AB with 5.2?
Yes.
Now we use the calculator here. So PQ is equals to 21.7 mod 1, 21.7 multiplied with 5.2 divided by 12.4. I got 9.1. Do you have your calculator with you?
Yes, sir.
Check, cross check my answer.
Yes, sir. It's correct.
Doubt. Do you have any doubt?
No, sir.
Okay. Let's move on to this one. Look, just this one is a class task. Okay. You don't need to worry whether you got it correct or wrong, but I just need to check how much you understand. So for that purpose, this is your class task. Do you have your rough uh, notebook with you?
Yes, sir.
Okay. So I want you to solve part A first. Don't worry about the solution. Just follow the rules that we have studied. It's okay to be wrong. Don't need to worry for the impression. Okay. Solve this one. I'm waiting. Once you're done, let me know.
So for part A, the answer is 7.5.
Okay, now go with the part B where you need to find y. Okay,
So can we use the same values as we use in part A? For example, if we take A,
exactly. Yes, you can use the same values. You can use the same ratio.
okay, so so for part B, answer is correct.
Answer is 12. Now let me check whether you got it correct. You got x as 10.5,
X is 7.5.
7.5. Let me check. A, D, B, E, and C, F. Okay. So y over 9 equals to 8 over 6. You got x as what?
7.5.
And y?
12.
Okay. You got it correct. Very well done. Understand question number 4. Two cylindrical cans are mathematically similar. So, is the information given about their similarity?
Yes.
Now, two cylindrical cans are mathematically similar. The larger can has a capacity of 1 liter, and the smaller can has a capacity of 440 ml. What does capacity means?
The how much a cylinder can hold or any object that is given, how much we can
Like
put in it.
in well, like just to make it, just to simplify it, what does capacity means? What quantity it represents? Capacity means what? Is that volume? That how much volume a container can contain? Is that what
Yes,
capacity means?
yes.
Okay. What about the units liter? What are these units used for?
For water or any type of liquid.
Which means the volume, we use liters for volume. Agree? And
I didn't
milliliter.
get your point.
You did what?
I didn't get your point.
Look, what I'm trying to say here is this: these units, 1 liter and 440 ml, what do they represent? Do they represent the capacity of a container?
Yes, a 1 liter is 1,000 milliliters. So
Very well done. That's what I need to like. I need to make clarification. You already know that 1 liter means 1,000 ml, and ml and liters are the units for the volume. Do you agree with that as well?
yes,
So, which means that the objects are similar. Which formula we are going to apply here?
V1 over V2 equals L1 over L2 whole square.
Exactly. Very well done. Now, just for your ease, I'm marking these two geometrical figures with 1 and 2 so that it will be easier for you to apply the formula. Then obviously D would be L1. Do you agree? And
Yes,
this 12 would be L2. Then this 440 would be V1. And this 1,000 ml, because we need to use 1,000 ml, not liters, because we need to make the units same for the ratio. So this 1,000 ml would be V2.
yes, sir.
Let's apply. So the formula is V1 over V2 equals to L1 over L2 whole cube. Agree?
Yes, sir.
Now, do you know how to remove the cube?
By taking the cube on the other side.
Taking the cube root, you mean?
Yes,
Remember
yes,
that we remove cube with the cube root and we remove square with the square root and vice versa. If you want to remove square, we take square root. If you want to remove square root, you take square. Okay.
yes,
L1 is replaced with or substituted with the D and L2 with the 12. Any doubt till here?
no, sir.
Now I'm taking cube root on both sides. You can't apply the cube root on one side because this is an equation, so you have to go with the both sides, okay? So 440 divided by 1000 equals to cube root of D over 12 cube. So do you understand that this cube will be cancelled with the cube root?
Yes, sir.
And we'll get the simple D. Okay, so now with the calculator, we need to find the cube root of 440 over 1000. So what you need to do, just press the fraction button in your calculator, put 440 in the numerator and 1000 in the denominator. And then now first you take the cubed root and then the fraction sign, 440 in the numerator and 1000 in the denominator. I'm getting 0.7605. Are you getting same?
Yes, sir.
So just keep that value on the calculator screen. Do not remove that value. Okay. Do not all clear. Do not do all clear. So equals to uh, D over 12
Yes, sir.
because it removed the square a cube root. And then just multiply whatever the answer on your screen, the previous value, just press multiply and press enter 12. Are you getting 9.13?
9.12.
So
Yes, sir.
diameter of this cylinder must be 9.127 means 9.13. We'll round it off to 13. And because it's a diameter, it's a linear unit. It's a linear dimension with the linear unit. Agree?
Yes, sir.
And the units are centimeter because that's what they're given in here. Out. Now, with the diagram, Irha, intelligently think. Do you agree that that our answer is correct? Because we are getting smaller diameter than the V2, than the diagram number 2.
Yes, sir.
For example, if you get D value as 15, would it be correct?
No, sir.
Why?
Because the size of the first cylinder is smaller than the other one.
Exactly. Because that these are the two similar cylinders, and the diameter for the larger cylinder is 12. So obviously, any value lesser than 12 will be acceptable.
Yes.
And in that way, you can understand that whether your answer is correct or not, just to make sure. Okay.
Yes.
Let's check the last time. I need to check the values just to make sure we didn't make any mistake while calculating with the calculator. So yes, that's 0.76. The cube will be removed with the cube root and it will be multiplied with the 12 to get, yeah, 9.13. Any doubt?
No, sir.
I'm not leaving these questions. I'm just leaving it for a while, just like question number 1 and now question number uh, 5. I'm just leaving it for a purpose. Okay. We're not leaving it entirely. We'll solve these questions. But first we need to first we need to just go through the easier questions, the simpler ones. Okay.
Yes, sir.
Just to make sure that we are applying the formula correctly, we understand this the thing, and then we'll move to these complex questions. Okay. That's a class task for you. Are you done? Do you find it
Sir,
a
it's
bit
not.
difficult?
Sorry, you didn't ask to solve it.
Sorry, come up again.
You didn't ask to solve it. I thought you were busy.
I didn't say, are you solving it or did it like what?
Sir, I thought you were busy and you muted your mic, so I thought that you didn't ask me to solve the question.
Oh, that like it's written above. That's a class task, and I mentioned that please solve it. This one is a class task for you.
So I'll
So
solve it right
you
now.
were waiting for me for that time period.
Yes, sir.
It's okay, that's a misunderstanding, but I already mentioned that you need to solve this one as a class task. Maybe you didn't heard that. So start solving it. Okay. Are you solving it now?
Yes, sir.
Okay.
So for finding the radius of the large cone, we can keep the base radius of small cone in like up or down anywhere.
Done. Are you done?
No, sir, almost.
Okay.
Sir, is the answer 6?
Okay, let me check. So it's V1 over V2 equals to L1 over L2 whole cube. Smaller cone base is 3. You need to find the base of the larger cone. So, okay, uh, 3 cube 27. And what number do you have got?
6.
I think that's wrong, but let me show you how we'll solve this question. Okay, the volume of two similar cones are 36 pi centimeter cube and 288 pi centimeter cube. The base of the larger of the radius of smaller cone is 3 centimeter. Calculate the base radius of the larger cone. So let be the base radius of the larger cone be R1 and the base radius of smaller cone would be R2. This one, because it's a larger volume, must be V1. This one must be smaller volume, must be V2. Because smaller we represented with 2 and larger we represented with 1. You can use either ways. Is that the formula that you have used?
Yes, sir.
So 288 pi divided by 36 pi. Do you agree that pi would be cancelled with the pi?
Yes.
Equals to R1. We need to find R1. Divide, maybe you are right. Just how much you've got?
6 and 6.
Very well done. You have got it correct. Any doubt?
No, sir.
You got it correct because this one R2 is 3. So is a cube here. So 288 over 336 is 288 divided by 36 is 8. And then we have R1 cube over 3 cube is 27. And then 27 times 8 is 216. And then you take on both sides and the cube root of 216 out in today's class.
No, sir.
I'll send some practice worksheet as well. Okay.
Okay, sir.
Do remind me about that if I forgot tomorrow, inshallah. And then we'll solve further question in our next extra class. Just keep track of the classes with Miss Madam Bajia because she will cover the other things and I'll try to cover as much as we can from similarity. Okay,
Yes, sir.
sure. How's your classes with Sir Muhit?
It's good, sir.
And I think they are covering the same topic that are for your assessment, atomic structure and configuration, electronic configurations.
Yes, sir.
Okay, so that's it for today. Thank you for joining the class. Recording is already available on the same channel, IGCSE Foundation. Okay.
Yes, sir.
Did you log in with the same user credential I provided you?
Yes, sir.
Okay. Thank you.
Allah
Assalamu
Hafiz, sir.
alaikum.